That should be capturing now. Okay, perfect. I'll go back to this. Okay, so do you guys know what hard water is? Anybody know? I'm gonna try and make this interactive if it works. What's hard water?
I think it has like things like alkali metals in them and stuff.
Yep. So it's got some. I think they're mostly alkaline earth metals. So that's a good review. It's group 2. So I threw up here. It's calcium carbonate and magnesium carbonate, and it's this stuff. I used to call it soap scum. I don't know if it's really considered. I don't know if soap scum is something different, but I just called anything that kind of collected on the end of a faucet or a shower head hard water. So it's basically ionic salts. So calcium and magnesium salts.
Oh no.
What's going on?
It's a foregone robot.
What's going on?
You're like cutting out a lot. I can't hear anything you're saying.
You're cutting out.
Uh-oh. Can you hear me now?
Yeah. Yes.
Okay, maybe I just need to talk like more directed to my microphone. Let's see. And I wonder, can I mute my audio mixer? Let's try this. Can you still hear me?
Yeah. I don't think it's the mic. It's probably just your Wi-Fi.
Okay.
That's my guesses.
Yeah, I don't know. Hopefully, no. I don't think my wife or Linus, they're not watching anything right now, so hopefully this stays okay. Also, I started recording, so right now it says my CPU's running at 15% and that everything's streaming at 60 frames per second, so it seems to be okay. Oh, anyways, these things that show up, calcium carbonate and magnesium carbonate, are they aqueous or solid? And would you expect them to be soluble or insoluble? This is kind of a weird question.
Are they solid?
They are solid when they form this scum on the faucet, but
I'm guessing the calcium carbonate would be solid.
yeah, both of them can be solid, but here's the weird part is, and see if I can do this. They're slightly soluble. So what happens is you get magnesium and calcium from your water source. So say you live out in the country and you have a well, and there's lots of magnesium and calcium carbonate in the ground. Well, those things dissolve, okay, and they don't dissolve very much, but they dissolve enough to they reach the saturation limit. So there's basically enough calcium and magnesium ions in the water, so Ca2 plus, Mg2 plus, CO3 2 minus. There's enough of those floating around in the H2O that water can't basically squeeze any more dissolved ions in, and it's fully saturated. So I don't have a good picture of this, but just imagine a lot of water molecules with a mixture of those ions in it. They're all spaced out equally, and there's just not enough room for any more. And you guys know, since we're going to talk equilibrium in a second, if there's too many calciums and too many carbonates floating around, as soon as they hit each other or find each other in solution, they recombine, and when these two things combine, they form a solid. So right now it's kind of right on the edge between like a solid and an aqueous. And so what we're going to talk about is certain salts dissolve and form like a higher concentration saturated solution than others. Some of them you can barely fit any ions in solution, and other ones you can more. Nature prefers to have more ions in solution. It has to do with the ion size, the ion charge, has to do with the how the polarity of water can rip things apart. And so that's kind of beyond the scope of this. So basically all we're doing is going to review equilibrium. So could you guys write an equilibrium expression for calcium carbonate? What would its equilibrium expression look like when it dissolves? So CaCO3, Evan says, is in equilibrium with what?
Ca2 plus and
Ca2 plus and, oops, I should not say and. plus CO3 2 minus. And I should probably put here, I need to put states. Okay, so there's that. And if I was to write out K, you guys remember products over reactants. So I would put Ca2 plus, CO3 2 minus, and then I'm going to put a little 1 down here for now. And do you guys remember? Oh, sorry. I'm going to move my video or see if I can scroll. Why don't I include the why don't I include the solid in there?
Because that's an infinite concentration, right?
Yeah, because
Yeah.
exactly, it's the weird thing.
Or
So the new part about this one, and we talked about it a little bit, like probably a couple months ago, is instead of calling it just K, they add in this little SP, and that SP stands for solubility. Oops. Stands for solubility product, and you guys know where the term product comes from because this is just a big multiplication. Does that make sense?
Yeah.
Okay, and so for this one, oh, we could write another solubility product for magnesium carbonate, but I just did this down here. It would look really similar, just replace the calcium with magnesium. But let me scroll over. Sorry. Where's my scroll bar? Oh, there we go. This is not working. There we go. Okay, which forms more soap scum? If I told you, let me erase this. Here's the KSP values. So which one of those will basically be less soluble in water, and why?
Magnesium.
Not magnesium. 50-50 guess. This one this one will form more soap scum. Why?
Because it's 10 to the negative 9.
Yeah, so this one is just, it's smaller. And what that means, so if I look at this, we got, oops, here, I'll write it again. KSP equals Ca2 plus CO3 2 minus is equal to 4.96 times 10 to the minus 9. And this is basically concentration of product over concentration of reactant. And let me move this down. Why won't it let me scroll down? Sorry, I'm not used to this. One note. There it goes. So, and remember, the products here, this was the solid on this side, is in equilibrium with the aqueous stuff here. So if this is the product side and this is the reactant side, then because that number is so small, this is a small number compared to 1, which is relatively large, okay, in comparison to that small number. So the dissolved stuff, the aqueous stuff, is in really, really small concentration compared to the solid. And again, we can't measure the concentration of the solid. It just forms that scum on your faucet, and it's just infinitely concentrated with calcium and carbonate, okay? And they're hooked together in an ionic compound. Does that make sense?
Mm-hmm.
Okay, I'm gonna go, I've got better questions now, I think. Okay, so these ones actually have some math in them. So let's see if I can move around. Sorry, got this auto hide. Okay, so here you go. Which results in a greater silver plus concentration? And I want you to compare these. And I think I've got something wrong. Just a second. I feel like that's way off. Let me look up something in my book. Silver. Yeah, that's 1.12 times 10 to the minus, not fourth, 10 to the minus 12th. Let me erase that. Oops. Okay, so look at those two. Which one, and can you guys give an argument, which one would give more silver plus when it dissolves? So say they start out both as solids. Oops. Okay. And you drop them in water, and you drop equal number of moles. So say you drop, I don't know, say you drop 1 mole of that solid in and 1 mole of that solid, and you stir them, and it dissolves slightly, but you know you've saturated. Oh, a big thing in AP chemistry, how do you make a saturated solution? Because a lot of labs call for saturated solutions. So say I have like water. Okay, I drop in some of the solid chemical that I want to dissolve. What evidence do I know that I've reached the saturation limit? Like what happens when I say add a stir rod, start stirring this? What's going to happen to these solid particles? What does it look like? And I wish I could like show this, because if we'd been in class, I would just like stir stuff and it'd be a lot more interesting. But what would happen?
If it's saturated,
Yeah, like how would
Eventually,
you
it will stop dissolving.
how would you know that it's saturated?
it doesn't dissolve.
Yeah, so this was, and it was Tyler and Evan and Arthur was there and Savannah was there. There was a couple people absent, but when we were doing that freezing point and you guys were making the sodium chloride solution and you were dumping
Yeah,
a ton of salt, eventually you guys reached the saturation limit. Was there salt at the bottom of the beaker?
Oh,
Oh,
yeah,
yeah.
there was a lot.
Yeah, so eventually you end up with solid and you're going to end up with aqueous, and which would be the dissolved salt, and you know that this is saturated. Okay, if it goes to just this, so say you end up with just aqueous, okay, like you add a little bit of pinch of salt and you stir and it all dissolves and there's no solids, and we say that this is unsaturated.
It's also perfectly seasoned.
Yeah, exactly. So you would there's times I think when you need saturated solutions, like for making ice cream. There's other applications of it too. Um, I'd do more research, but there's certain things in cooking where you'd want saturated solutions of salt and sugar.
What why does raising the temperature increase the saturation point?
Okay, so that's just a kinetic energy thing. So again, like these little particles of water, if they're moving around and trying to break apart, say, a plus from a minus, so say you have a solid, which is just a positive ion and a negative ion, if that force vector is bigger and it hits the ion, you could consider it hitting. It's not, this is a simplification, but if it hits it harder, then it's going to break apart easier. So that's why, right, when you need to dissolve Jello, you dissolve it in hot water and it dissolves faster. You could dissolve it in room temperature water, but it's going to take a long time.
Okay.
Yeah, and it has to also do with the stability of the little globs of water surrounding the ions. But again, that's probably more complex than it needs to be. Just think of it as faster moving water molecules can rip things apart better. Okay, so here you go. Why, if you had to give an argument, because there's arguments for both. Why would this yellow one? Why would it like lead to, say, a lot of Ag plus in solution compared to the other one? What's true about this KSP value?
The
The KSP is larger.
It's larger. So
It would dissolve.
yeah, there you go. So one argument for why do I so for silver Ag chloride to be more soluble would be that the KSP is larger. And then for this one, what's an argument as to why that one would contribute more silver?
It has twice as much silver.
There's too much
There you go.
silver
Yeah.
for this one.
There you go.
What would that one like trump the other one because the KSP is not an order of magnitude larger?
Well,
Like,
so
same
this
order of
this is
magnitude?
why, and I tried to pick an example. I picked like 2 or 3 examples to work, and again, there's no way we can cover everything in the book. I like got overwhelmed this morning when I started looking at chapter 16, and I was like, oh my goodness, there's no way we could cover this all without being together, and I got kind of depressed. And then I realized, like, okay, AP, the book that you're reading is a lot heavier in the chemistry stuff than AP chemistry than the exam will be. So I think this question would be something that you'd see on the AP exam. And what you're thinking, Arthur, there's no like rule of thumb as to which one trumps the other. And so we're just going to go through some calculations. So I picked some ones where we're going to use an ice chart and we're just going to compare. But I would say that this is kind of, again, on the like towards the more complex level of what's going to be on the test. I just hopefully by the end of this, you guys have a little basis where you could read chapter 16. I'm probably not going to assign much work. I think the only work that we're going to do is going to be practice test problems at this point. I'm going to keep watching more of the college board videos, and I'm just going to pick questions, and I have to figure out what distance learning for all means for AP chemistry, but my guess is it's just going to be a bunch of practice problems and office hours for you to ask questions. So this might be like the last lecture for a while. So anyways, sorry, I'm rambling. Let's just calculate this one. So do you guys have those KSP values written down?
Yeah, hold on, let me get that.
Can you guys write those down? Because I'm going to ask you for them because I'm going to flip to a new slide and I don't want to have to go back and forth.
Okay, got him.
Okay, so if we set up, let's write out the first one. It was AgCl solid in equilibrium with Ag plus aqueous plus Cl minus aqueous. Okay. Okay. Again, we're just gonna do a little ice chart. The solid doesn't matter at all. So if we say start with pure water, which is 0 molar, I'm just going to put M to remind you. Ice charts are always done in molarity. So 0 molar, okay? Then what's going to happen as this stuff dissolves? What's going to happen to the concentrations?
The concentration is going to change.
They're going to change. And we don't know by how much, so we just do the X. This becomes kind of trivial for solubility products. So 0 plus X just ends up being X molar, right?
Yeah.
So
That's nice and easy.
we're interested in this X because the question was which one contributes more silver. So you write out your KSP, which would equal this concentration times this concentration, right? Just the two equilibrium concentrations. So just X times X, which is X squared, which is, and oops, not square root yet. Arthur, what's the value?
1.77 times 10 to the negative 10th.
Okay, so it's just X squared equals KSP. This isn't always going to be the case. You'll see in a second. And then if you're solving for X, you just take the square root. So if I say X equals the square root of that, I was good and I went and I got my calculator ready. So hopefully this works. Oops, I wanted it on top. No, I can't turn it on. Just a second. Exit.
Have you tried changing the batteries?
Yes. Oh, there it goes. Arthur, thank you. I just needed to change them. And actually, check this out. I feel more prepared teaching this way than I do in my classroom. I think it's something about my classroom. I even got extra batteries for my pen, and I haven't had my pen die once practicing.
Don't jinx yourself.
Your
I
pen
know.
will die immediately now.
I know. So let's see. Second square root. Oops. Second square root. 1.77 times 10 to the minus 10. Okay, so 1.33 times 10 to the minus 5. I'm going to go back. 1.33 times 10 to the minus 5. Okay, so does that make sense? So here you go. What if I put this? This would be crazy. What if I put like 1 pound of silver chloride, which would be a lot, versus like 1 gram versus 1 ton, and I put all that in, like, let's say, I don't think you could squeeze a ton into a liter, but let's just say you put that into a liter of water. What's the maximum concentration of Ag plus that you're ever going to get in here? That would be the 1.33 times 10 to the minus 5. So as long as you put in enough moles per liter, that's going to be the maximum amount. And as soon as you surpass this value, then it just basically doesn't dissolve anymore. Okay, so that's that one. You guys already maybe thinking ahead of what's going to happen with the silver chromate. So let me do a new window. Ag, was it CR, what was he, silver chromate, CR, Ag2, CrO4 solid. What happens when this one dissolves?
Oh, you get twice as much silver per
Yeah.
unit.
So you get 2 Ag plus, and you get a CrO4 2 minus. And I could put it like this. Okay, so these ones don't matter. How much do I gain when this starts to dissolve? So let's see, I'll set this up formally.
So it's gonna be 2x.
Yeah, so you get
X.
2x and you get x. So at equilibrium, you get 2x and x. And so when you write out your KSP value, it's actually, okay, how would you do this? Concentration of products over concentration of reactant, and see if you guys can get it. So
Okay.
concentration.
So would it be
2x squared.
Yeah, I'm gonna
2x
have 2x, and
squared
this
and
is the
then
important part.
x?
It's 2x in parentheses squared, because you have that whole concentration squared, and then times this concentration to the first power, and again that 1 and the 2 just come from, oops, those numbers, right? So those correspond to this. So the big thing, AP will try and trick you. This doesn't equal 2x cubed. This equals 4x cubed. So that's, I don't know if they'll ask a question regarding this, but that's the common mistake. People think that this simplifies to 2x squared, which is not true, right? And so you've got to account for distributing that 2x, or that 2, multiplying the 2 times 2. So you end up with 4x squared there, which makes 4x cubed. And that equals, Arthur's got it. What's the value?
Wait, hold the 1.12 times 10 to the negative 12.
All right. So because of that stoichiometric 2, it messes up. It doesn't mess up things. It's just more to account for. So when you solve
Wait,
for,
so do we have to
yeah,
cube root it?
yeah,
Or-
eventually. So right now we're gonna
Okay.
just divide by 4.
Divide by 4 first.
Yep, divide by 4, and then take the cube root. Take the cube root. I get x equals. So on my calculator, let's see if I can switch to it. So I would do, oh, I want that on top of my screen. Let's see if I can do that. Nope, it won't wait, what if I bring it up? Just a second. What if I bring it up here? I gotta figure out how to do this more streamlined. Nope, it doesn't let me. That's really weird. So it was 1.12, oops, 1.12 times 10 to the negative 12. Okay, enter, divided by 4 to the parentheses 1/3 power for cube root. So Oops, and I did that twice. So the first answer, 6.54 times 10 to the minus 5. 6.54 times 10 to the minus 5. Okay, and that's molar. That's X. So then how do I get this concentration here?
It's 2x.
Then you have to double it. So yeah, you're just gonna take that, multiply by 2, which, see if I can do this in my head, it would be 1.38 times 10 to the minus, or something. Let's just say 1.308.
8.
Is it 1.38?
Mm.
I can't do this. 1.38 times 10 to the minus 4.
It's 1.38.
Okay, 10 to the minus 4 molar equals the Ag concentration. Oh, and concentration, you'll see it in your book more and more. It's in square brackets again. So if you see that on the AP test, it means what's the molarity. So, okay, so then comparing, looking at those two answers, I got to go back out of my full screen. So it was this one, which was 10 to the minus 5, I think. So 10 to the minus 5 versus the one with 2 silvers. The silver chromate was 10 to the minus 4. So if you were trying to get silver in solution and you had both of those chemicals sitting on your shelf and you saturated the solutions, you could get more silver in there with silver chromate. Okay, so that's kind of that's the mechanics. What's up?
No, like, hold on. I haven't assembled the expressions real quick. So like on the second problem,
Yeah.
in order to get the expression, so like you got the 2x squared and that's times another x.
Yeah, because
So like
I have this chromate ion also, right?
okay.
So I had
Yes, and then
2 of these and 1 of these.
okay, and then I thought like if you had like multiple something in the stoichiometry, like you would just put it to that exponent, like
Correct.
like
We did.
okay.
But what this first 2, the one that I'm circling, that 2 represents that when it dissolves, you are basically ending up with twice the amount of silver as you are chromate.
Okay.
So
you both multiply the x by 2 and you put it to the second power.
Correct. And so these numbers here come from, I would say, like this. Okay, and then the reason that I did, let's see if I can highlight them. The reason that I did this 2 and this one, that's because that's the definition of K values, and those came from these numbers.
Okay, so you get the number like multiplying the x from like what's being in the from the ice
Correct.
chart,
You get
and
that
then the
from
exponents come from the stoichiometry.
yeah. You get the actual like from the chemical compounds formula. You get like the basic quantities, how they dissolve, and then yes, you get your exponents in your K values. You get that from the stoichiometric coefficients.
Is there ever a time that the ice chart will like when you're doing the algebra will like be different than the stoichiometry?
No. So KSP
Okay.
values, yeah, you could probably like let me do another page. Like if you got say it was another one, Na3PO4, and sodium phosphate. Well, okay, sodium phosphate's not a good example because it's always soluble. Let me come up with something that's not soluble, like Ca3PO4 2. You could cut to the chase that the KSP would be equal to, well, it's going to have 3 calciums, so that would be 3x to the third, and it's going to have 2 phosphates, 2x squared, which would equal some value, right? Like KSP value you could look up, and then you'd have to do this out. This would end up being 27x cubed, and then this would be 4x squared. And so you'd end up with, what is that, 54,108 x to the 5th equals that same thing. Does that make sense?
Yeah.
And it all came from the 3 and the 2. So whenever you're talking about solids, and this is like, if you hear the word precipitate, or you hear solid in solution or saturated solution, it's probably a KSP problem. And you can write out your ice chart, or you can just jump to KSP. And the really easy ones, like, things like calcium fluoride, CaF2, or I guess I could go even easier, CuS, copper sulfide. Then again, that one, since it's just a 1-to-1 ratio, that one ends up just being x squared. And since this is a 1-to-2 ratio, a lot of chemists, they end up recognizing that as a 4x squared because it's 1-to-2. There's lots of things you can memorize. I was never good at memorizing them, so I would just write out the ice chart. Okay, let's see what time. I gotta keep myself going. 10:40. I got like one more example and one more good question, and then I gotta save some time at the end. If you guys have questions, let me see if I can get to this. Okay, so here's calcium hydroxide, and we would do this like lab and figure out the KSP value and do some different titrations with it had we been in class. But how does the addition of common ions affect solubility? So here's the KSP value for calcium hydroxide, and we're going to compare if you dissolve it in DI water versus dissolve it in a calcium chloride solution. So we'll do a little bit more algebra. We'll do 2 more ice charts, and then I think that's about it. But let's see what happens when this dissolves. So calcium hydroxide goes to calcium plus 2 hydroxides. And I get 0x, 0, 2x. Sorry, that was a good yawn, Arthur.
No, thanks.
Yeah. Okay,
I blame Kayla.
so this ends up being one of the ones, and I mean, there's only so many examples we can do. It ends up being 4x squared, right? Because when you end up squaring this one and multiplying this one to the first, 4x squared equals. Oh, I think I jinxed myself. I think my pen died. Hold on. Something bad happened.
You still there?
Are you guys still there? Let's
4x cubed.
Yeah, just a second. What just happened? Yes. I lost my whole like screen and everything.
Oh.
Yep. Let's see if I can finish this out. Like, it was all going so well. I had my Surface Pro connected, and then all of a sudden everything went away. Something went wrong with the projection. Something went wrong with the projection, it said. Try connecting again. Oh. Give me a second.
Oh,
I
boy.
can still see.
Yeah,
Never mind.
Yeah, can you still see my face?
I can
Yes.
still see your face, yeah.
Yeah,
I can see half of your face.
Okay, give me a second. I gotta
Now
reconnect
there
to
we
my.
go. There you go.
Let me reconnect to my Surface Pro. See if this works. My gosh.
Why don't you just get a whiteboard in your house?
Oh! I think I'm gonna be okay. I think I can recover. See, I'm almost there. Hey, I recovered. So, okay, so 4x cubed, sorry, that's what you guys were saying, equals 6.5 times 10 to the minus 6. So divide by 4, take the cube root.
Cube root.
Yep. Could somebody do that?
Vincent, I assume you have a calculator on hand.
No, it's done.
Oh!
I'm shocked.
I can do it too.
No batteries.
It's like, I don't have a calculator on me, and I
Okay,
don't
that's
know
okay.
what
I'll move it
happens at
down.
the
We'll do
tab.
it. We'll do it. I don't know why it won't let me put it on top.
I got it.
Okay, let me go back. Okay, what did it come out to?
1.176 times 10 to the minus 2.
Okay, so that's if it's just in plain water, right? So that's what happens. That's how we solve our KSP. But I want you guys to think through, and we're almost done for today. What would happen if I put this, instead of in distilled water, I had a solution of calcium chloride, like underlined in red, and then I sprinkled in some of this calcium hydroxide solid and tried to dissolve it? Would more or less dissolve, do you think? And why?
Plus,
Less.
the space is taken up.
Why? Yeah, the space is taken up. And so think about this. Think about this expression. And now, since it's in calcium chloride, won't the calcium 2 plus be much higher in concentration? So in terms of Le Chatelier's principle, if you increase this, which way does the reaction get pushed?
To products.
It gets pushed to the...
I mean, the reactants.
It gets pushed to the left. Again, it's kind of weird. I always just say left or right. Le Chatelier's will try and decrease the calcium concentration by pushing itself to the left, and it's going to form more of the solid. So if you want to think of it this way, like forming more of the solid means less of the solid will actually be able to dissolve. So what we should do when we solve this one is it's going to end up with a smaller concentration for X. So let me do this again. I'm just going to rewrite this CaOH2 in equilibrium, calcium plus 2OH minus, except this time the initial concentration, you guys see how this is a little different? It's not 0. This came from 0.5 molar CaCl2. And since I get 1 calcium for every 1 unit, then I end up with 0.5 molar calcium. So I still am going to gain X, and I'm going to gain 2X. Except now I've got 0.5 plus X and 2X
So it's just like a normal equilibrium expression.
Yeah.
Wait, where does the CL go?
Which one?
The CL, the CaCl2.
Oh, okay. The CL, yeah, the CL is floating around, but Cl minus is just a spectator.
Okay.
Because Cl doesn't show up in here at all, so the chlorine's not affecting anything.
Okay.
Okay. Now, truthfully, it does affect a little bit because it's similar to like a hydroxide ion because it has a similar charge, but it's negligible for us.
Okay.
So when I write out KSP, it's going to be 0.5 plus X times 2X squared. Yeah. Now, since what was the K value for this one?
6.5 times 10 to the negative 6.
Yeah, let's just say this. This is a small number. So because this is, and most times we're going to deal with things that are like 10 to the minus 10 or 10 to the minus 12. We're going to make the assumption, we haven't done this in a while, we're going to assume
that is going to be about equal to 0.5.
X is small. Yep. Compared to 0.5. So we're going to say that that's approximately 0.5. Okay? Yeah. So really, you can replace this with just 0.5. For all approximations involving KSP, that's a good assumption for AP chemistry. So when you're talking about how things dissolve and they're not soluble means you can make that assumption. Okay? And then we just go through and do this. So 2x squared is, what is that, 4x squared. So I get 4x squared here. So a half times 4x squared would be 2x squared. 6.5 times 10 to the minus 6. So on this one, I just need to divide by 2 and take the square root. So let's see if I can do this. Divide by 2, take the square root, and I get x. See if Evan can do it for us.
About 1.8 times 10 to the minus 3.
Okay. And so this one was the one dissolved in calcium chloride. And then the one dissolved in DI water, x was 10 to the minus 2, right?
Yeah,
What was the value?
1.18.
So, hey, do you guys see when I added some extra calcium, what happened to the solubility?
It
It
decreased.
decreased because, and you could just predict that. Let me scroll back up. You could predict that because we added some extra calcium. So what it did is it kept this stuff from dissolving, and because that stuff was kept from dissolving, then this concentration, the calcium concentration, is low. X is low. So that's Le Chatelier's principle. It's called the common ion effect. And the last little question, we're not going to solve anything for this one, would be, what about adding an acid to this same chemical? So let me write it out. This is the third time I've had to write this one. Ca2, oops, 2 plus 2OH minus. So question, what happens if you add, let's say, nitric acid? What will happen to the solubility of calcium hydroxide? Will it become more soluble and shift to the right side, or will it become less soluble and shift to the left side? What do you
I
think?
think, does it become more soluble because the acid will dissociate and then the hydrogen ions will combine with the hydroxide ions?
Yeah, oops. I can't write today. There you go. So H plus the hydrogen or the proton plus the nitrate, when that dissociates, okay, it forms a bunch of this, which combine with this. And when those react, right, that's a neutralization reaction. So think of it this way. What's going to be happening to the hydroxide concentration as you add acid?
It'll go down.
It's going down. If this is decreasing, that's considered pulling the reaction. And which way would the reaction get pulled?
The products.
It gets pulled to the right, yeah. And so this would be considered more soluble. So this is how we get things to dissolve. So like that's why if you look at some of, and this is calcium hydroxide, I know, but same thing with like calcium carbonate. Calcium carbonate does something a little different. Ca2 plus CO3 2 minus. This one, when you add some H's, you end up getting some carbon dioxide and water. Let's see if I can scroll down.
That should be CO3 2 minus.
You get what?
That should be CO3 2 minus.
Oh, CO3 2 minus, thanks. So here, you'll end up forming some, when these combine, the H plus and the CO3s, you end up getting CO2 and H2O. And I'm not going to take the time to think through the balanced chemical reaction. But what happens is, because of this reaction, you end up pulling the reaction to the right. And so if this is a solid, which is the soap scum, okay, if you want to get rid of soap scum, this is why most cleaners, like if you go look at shower cleaners, they're going to contain some dilute acid in them. Or actually, this calcium carbonate, you guys remember titrating that pink solution, the Nespresso descaler?
Oh yeah.
Okay. Well, the descaler, do you guys know where the word descaler or what a scale is? So like think of and I can't really draw them good, but I think it has to do with actual fish scales or dragon scales.
Yeah,
Or-
usually with deposits formed, like it kind of makes that little swirly pattern. Like there's a little bit on my shower right now. In fact.
Correct. Yeah, this is called scaling. Okay, and that scaling is formed by calcium carbonate and magnesium carbonate. And a descaler, okay, we used I think it was lactic acid. Lactic acid was in the descaler. That lactic acid basically reacts with the carbonate. Okay, so when you have H plus from lactic acid and the carbonate reacting, then that'll cause the calcium carbonate soap scum or whatever is built up in your coffee maker. It causes it to dissolve. So this is how we like shift equilibrium. So a lot of cleaners and things to dissolve that, all they're doing is using Le Chatelier's principle to pull something to one side. So, and I think that's where I've got to stop. Do you guys have questions? I know that's a lot, and I don't know how effective it was. So I think the most effective would be I probably will be emailing out some like test questions or problems to work on, and then next week we're gonna start having office hours. So I'll give some practice problems and then be available during office hours. But I don't know what's gonna be most effective for you, and I apologize. So I will post also the video recording if I went way too fast. But I would also say reading the book and trying problems on your own and then coming to office hours, that's probably going to be more effective than rewatching the video. But do you guys have any questions like right off the bat or things to talk about?
Yeah, this was called the common ion effect.
Yeah, this is common ion effect. This was like the end, so like I got kind of worried. AP told us that we're going through Unit 7. This was like towards the end of Unit 7. So I think this will be kind of the last stuff that's on the test.
Okay.
The other thing that worried me too is we spent a lot of time doing titrations and we started talking about the Henderson-Hasselbalch, and that's actually turns out to be in Unit 8. So it's good that we talked about it and it's important, but I don't know how much it's going to be on the test. So that kind of sucks. Like had I known that this was, foresight, had we known we would have been shutting down school, we would have talked about the common ion effect and done all the demos with it rather than doing all those titrations. But
yeah,
we didn't know.
Yeah, we couldn't have known.
Yeah. So,
So you think if I just go on like Khan Academy and search this up, I could find some videos?
Yeah, you should be able to do. Let's see, who would be? I bet Khan Academy. It might be kind of sketchy. Let's see if I can try this since we're here. Control Alt Screen. Sorry.
Whoa, did anyone else see that?
Yeah, the infinite mirror. Infinite mirror. Okay, let's see.
God.
Okay, can you guys see my Google?
Yeah.
Yes.
Okay, so let's see. Khan Academy Common Ion Effect. Videos. See, I bet his video is going to be very similar to what we just did because he said there's an ice table. So I bet it's going to be like basically the same. Oh yeah, see he's doing it with PbCl2. So yes, there's going to be some. Oh, and hey, here's better. I bet there's going to be, yeah, here's a free response question number 4. I have it muted right now. Hey, yeah, so this actually wouldn't be a bad thing to watch and do. And actually, oh yeah, this is exactly what we just did. Calculate the molar solubility of calcium hydroxide in calcium nitrate. And so yeah, there's some good stuff on Khan Academy.
Okay.
And I will start sending out, let's see, the test is May 7th, which is about a month. I'll try and send out like about one practice test a week. So like I'll send out 3 response questions that kind of equate to about an hour worth of work. Again, I don't know how I'm grading you yet. I don't know anything. So again, don't worry about your grade in AP chemistry because nobody's going to know any better. I'm just going to mark that you get full credit for the test. And I think just give you guys A's for the grade. But it's more of, if you want to pass the test, I recommend doing test problems about 1 to 2 hours worth of test problems, or maybe 1 hour of test problems and 1 hour of reading a week between now and the test. So you've got 5 weeks before the test. If you're doing 5 hours worth of sample test problems or more, 10 hours worth of work, you probably will have a good shot of passing the test.
Okay.
So, but I'll email out what I can. I don't know. I'm gonna flood you with stuff. If you ever feel flooded, then just remember we're in a really weird situation, and whatever you do is fine. And pass or fail the AP test, it really doesn't matter in the long scheme of things. So more of staying healthy and having fun, and like I restarted reading my biochemistry book just because I wanted to see how this whole DNA and immune system and like replication of viruses works. So I kind of got all nerdy, and before I go to bed, I like read biochemistry just because I like doing that.
I started reading ahead of the book and like other things because I wanted to learn about electrochemistry.
Yeah, and like
Yeah.
I know, I don't know. It'll be interesting to talk to you guys when you're off in college, and I know it doesn't apply to Tyler and Vincent, but when you guys study stuff, you always feel free to contact me and ask me questions, or say you do something really cool in class that you want to share. I've really enjoyed getting feedback from like Savannah Harvey from her chemistry classes, and hearing from Sam in his engineering classes. I don't think we have to like stop doing stuff, when you graduate. I also don't think if you want to not think about chemistry once you're done, I'm not going to hold it against you if you never talk chemistry with me again. But yeah, like I don't know. I'd rather see you guys enjoy the subject and practice taking tests, because you will take a lot of tests in college. So the AP exam's a good practice test, but don't feel bad if you don't do good on it or you don't feel ready for it. It is what it is. So okay, what else? I'm ranting a lot.
Okay, I actually need to go now.
Okay. Well, then I will just keep in touch. You guys always feel free to email me, call, like remind. If you need help, just get a hold of me and I will figure something. I can do problems online. I don't know. We can figure it out.
Okay. Thanks.
Yep. Okay.
Yeah.
Anything?
Have a nice
See
day.
you, Arthur. Anything else? Otherwise, I'm gonna go get ready for my next meeting.
I think that's it for me.
Yeah.
Okay. Sorry it went long. I will try. They told us 30 minutes per day per subject is kind of the rough guideline. So I got to get good at doing like 20-minute lectures and being done. So
I mean, like, I wouldn't mind spending more time on like AP chemistry and calculus than 30
yeah.
minutes.
When I was talking to your mom, Evan, too, I was brainstorming in my head. I think calculus and AP Chem, those are 2 classes where this kind of stuff like works, like online lecture. So
Mhm.
I think what I'd like to do when we start having these office hours is I'm going to try and ask Dr. Wagner if I can just do an hour of office hours, like a true hour just dedicated to AP Chem. And probably the best would be to just give you guys a problem or 2 a day in advance, and then show you the solutions or have you ask questions about it the next day during office hours.
Yeah, that'd be nice.
Okay.
Yeah.
Because it's basically starting next week. Teachers are kind of we're gonna have to be around more. I kind of have been working on house projects and not thinking about school a lot, but we'll be around more. So I don't mind dedicating lots of time to AP Chem if that's what you guys want.
Yeah, that'd be great. Thank
Okay.
you.
Yep. Let's see. Other than that one, well, okay, it lagged out one point, and then also my Service Pro disconnected. Was it legible, and was the audio good enough to actually get stuff across? Okay.
Yes.
Yeah.
Yeah, most of the time it was pretty good.
Okay. All right, and then I also want to try YouTube streaming, so I might try that with my physical science class. But I don't know. I'm a nerd, and this stuff was really cool. Like, I could tell Evan, I've got like my Surface Pro is being. I know you guys can't see all my screen, but I've got my Surface Pro as an extended desktop with like Wi-Fi screen sharing. So I'm using my Surface Pro, and then I've got OBS running on my laptop and like collecting, and I'm like learning how to do scenes. So it's like really fun because I can put up my slideshow. I can put up my whiteboard, or I can put up like my screen, and I can alternate between them with hotkeys. So yeah, look how little Arthur looks.
Oh my goodness.
Oh.
Yeah, there's Evan. Do you guys remember what was Ethan Oliver?
I think so.
Yeah, he was at our school for one year. There's Keaton and Arthur. Yeah.
What are they doing?
They're pulling asphalt. So this guy, the guy in the middle, he was one of my students and did the robotics program like in the first year. And he works for Malarkey. He makes roofing shingles, and he came and he brought asphalt samples. So that was like black asphalt that they were stretching. It started out 1 foot long, and they stretched it to like 10 feet. Vincent probably remembers.
I do.
Yeah.
Was that last year?
It's crazy.
Oh yeah, and Evan was there too, right?
No, I wasn't there.
Oh, you weren't in pre-engineering that year, were you?
No.
No. Okay. Well, stay safe. And I'll check in with you guys. Let's see. Today's Thursday. I'll probably check in with you and start sending stuff out like Sunday or Monday, and we'll have regular office hours starting sometime next week.
Guys, guess what?
What?
My birthday's on Saturday.
Whoa!
Ooh.
Happy birthday!
I know.
Happy
I'm so
birthday.
excited.
Do you get to do anything fun?
Probably not. I think the most fun thing I'm gonna do is make strawberry lemon zest cupcakes for my birthday.
Whoa.
But yeah.
Do you? Let's see. No, I don't know how much you guys have been seeing extended family. Are you just stuck completely at home with just like your parents and your siblings?
Yeah, it's just me,
Pretty
my
much.
mom, my sister, and my little brother.
Okay.
Keaton's all by himself basically,
Crazy.
and I got a lot of people in my house actually. But.
Yeah, I talked to your mom. She was very positive through, like, she was excited to see the school doing stuff and trying to start school again and help with meals. And I heard, what was it, Evan? Your mom said she served 500 meals at
Yeah, she went and
Lewis and Clark
helped out.
yesterday.
through meals.
Wow, that's awesome.
Yeah, they're serving like 500 meals out of Lewis and Clark, plus additional meals out of the Plymouth High School. So there's a lot of people who like are benefiting and needing that service. I'm signed up to help for 1 week, or not 1 week, a couple days next week. But part of me is like paranoid. Like I haven't even gone out really. I've gone to my parents. I've gone to my parents' house. I haven't been like around out in public doing things around other people for like the last week and a half.
Yeah, and there's a case in Columbia County already.
Yeah, it's creepy.
Yeah.
I also heard, and not to be gross, I was reading articles last night. Some of the symptoms, like you could be healthy and like only experience minor symptoms and like have it and spread it to many other people without even knowing you have it. Like some of the symptoms were like you've got diarrhea. Like diarrhea is not uncommon. Or you've got what was the other one? You're waking up feeling not rested and slightly confused when you wake up. That's a symptom. I'm thinking like that's like every time I wake up. Yeah, every time I wake up I'm slightly confused. And it was all these really weird things. They said like 10% of the cases in China that they reported and found and tested for, these people felt like completely healthy. So I'm like,
Jeez.
I don't know. That's what scares me. I'm like, I don't want to go out in public if I like say go out, get it, have it, and then I don't know I have it. I don't want to give it to other people.
Yeah.
So,
There's probably like a lot of people that have it and just don't know because just
yeah. Which is good and bad because it's scary to hear that. Did you guys hear like in Spain, the mortality rate right now is about 10% of the of the confirmed cases. About 10% of the people who have it that they've tested for end up dying. But so it's good if there's a bunch of people who have it and don't know, then that makes the mortality rate a lot less, right?
Yeah.
And so yeah, just creepy. My
Of
wife.
course, if you think about it,
Yeah.
it's easier to catch cases if you know you have it. So the people that are easier to tell are also usually the people that are more likely to die. So the mortality rates are probably higher than they actually are.
Yeah. My wife was showing me some of the modeling. I think there's something. It might be University of Washington or Washington's. It might be the Washington State Department of Health. They've got some really cool models where you can manipulate things, and you can. They're showing projections of when things peak. So I think they're saying like last week of April in Oregon, or maybe first week of May is when we're supposed to have our most cases. And it shows the hospital bed capacity, and it shows a bunch of other things on there, and it has like statistical error built into it. So even if their models are slightly off, it'll show kind of relative to the error how much, where we're going to hit capacity. Right now, Oregon is still underneath the hospital bed capacity, so we've got enough hospital beds for our projections.
Jeez.
Oh, by the way, have you been on Discord at all?
A little bit. I was trying to play with it for some other stuff. I just saw a bunch of pictures of people wearing their Shrek shirts yesterday.
Yeah. So I was gonna note, I got contacted by a Meme Machine, and they're working on 3D printing like hospital equipment. So I can get you an email for the guy who's in charge of it if you want to. I know you have a 3D printer.
Yeah, hang tight. I'll show you something. I gotta go grab it.
Let you go. Screen.
Sorry, it's gonna be small down in the corner. Let's see if I can make it bigger on my. Let's see if I can do this. Does this make my picture larger?
Mm-hmm.
Okay. Yeah, so I printed one of these. The National Institute of Health put out this one. It has a forehead visor, and then like nobody has the plastic. You need like PET plastic for the face shield. But I tried one, so I will print more for Mean Machine if they want. Do you have a 3D printer?
I do not know.
Yeah, we could try some. I guess I could run into the school. Although the ones at the school have pretty small print beds, don't they?
Mm-hmm, yeah.
Yeah, this visor barely fit.
Mm-hmm.
Oh, some of the rapid manufacturing ones, right? They might fit.
I think a couple of those are larger.
I could talk to Miss Adams. Maybe I could run them in, wipe them down, and drop them by like yours and Arthur's, or maybe the Shield's houses. So send me the an email with the Mean Machine kind of project, and I'll talk to Miss Adams. Okay, I'm gonna stop the recording and I'm gonna head to my other meeting.
Okay.
All right.
Bye.
Bye.
See ya.